Okay, ladies and gentlemen, welcome to our webinar entitled Color Expectations in Modern Color Workflows, Media Relative Color Reproduction. This webinar contains results from a closed project here at FOCRA termed Basics for Standardization in Toner and Inkjet-Based Printing. Let's come to the agenda of our presentation, and it is the role of color reproduction in the graphic arts production chain. We will then talk about color rendering from a technical point of view. Then we will introduce the media relative reproduction and explain how to use it in typical environments. And then we will give you some details how you can actually implement it on your own and use it on your own. At the end, we summarize with some different levels of predictability, and then we'll give a summary. Color expectations vary over the time, and if you see what happens in the printing industry, you see that the PSO or 12647-2 ISO standard only complies by means of a yes, no, on, off way of interpreting color. That means if you are in the standard or outside, there's just one set of tolerances. However, there are many different ways of handling tolerances. Like if you go to a hotel, there are 5-star hotels and 4-star hotels. And other systems like System Brunner in Switzerland implemented different multi-level tolerancing for judging, assessing colors across channels. And that is kind of what we see here at FOCRA, that there are different levels and different types of use cases and ways of viewing printed images and printed matter, and therefore we must reflect that. And this is the way I summarize the whole webinar and the whole concept here with the term printing the expected. That means understand the expectation and then as a service provider try to meet that expectation. But you will see and you will know better than we do mostly that those expectations vary across customers. And if you talk about expectations, then we have some provisions, mechanics, and if you read 15930, the PDFX standard, it is all about the dissemination and the predictability of the dissemination of compound entities. So it means I have a PDFX file and I would like to make sure that this is what I see across different channels. And this is what we see here on the presentation. Coming towards color rendering and color reproduction, in German terms, it is even more complicated, and in English terms, it's a little bit easier. But from a color scientist point of view, it is important to understand that color rendering is a property of an illuminant, and it is defined by the CIE and used with color rendering indices of different types. There's a common general color rendering index used also in the graphic arts, and this is quite nice. When we talk about color reproduction, we mean something different, and here I like the proposed levels from Mr. Hunt, and these levels were fine-tuned by Mark Fairchild, and there are different levels of color reproduction, and everything we see basically is can be sorted into or grouped into one of these categories. Spectral reproduction between the highest level, really reproducing the spectral reflectance factor. It's a niche market, of course. Device mode is kind of something like what we typically see when data is just sent to a device and displayed as is. Pleasing color production about acceptable reproductions. What we talk about mostly here is the ICC. Colormetrical reproduction, we will come to that later. Appearance reproduction is something where we have different surroundings, viewing conditions, and we take care about the impact of them with nice and technical models like CCAM02, and the color preference reproduction, which is the best possible reproduction. I tell that here because I would like to make sure that we don't confuse color rendering from color reproduction. When we talk about standardization and everything here in that context is about standardization. Then we talk about objective evaluation. It is the main fundamental of FOCRA, is where you can measure, there is no reason to dispute. And that's why we will always try to look for something which we understand. And color measurement, as you know, must reflect what we see. Otherwise, in most cases, it makes no sense. There are other applications for recipe and kind of ink formulation, but mostly color measurements must reflect what we see. And color science provides established means for evaluating small and medium color differences, but not yet huge differences. So that means all the color science concept is more or less derived by those experiments in 1931 and before, and later, of course, where we have displayed objects viewed side by side, and then derived the differences and the findings from that. And that is mostly objects seen side by side next to each other, and there are the ways to determine the color matching functions and the colorimetry based on that. So for color differences seen in different modes, different ways, different levels of presentations, side by side with a small separation or not perfectly side by side, we talk about color differences. And in my opinion, color science has a good understanding how to judge that. Of course, there are something open, some small things, but generally we understand that good. However, for huge, very large color differences, there are kind of bigger picture concept necessary, like color harmony and different ways of understanding mathematically what the perception of those kind of different colors are. And here I think we don't have right now a set of mechanisms to understand that in an objective way. So that's why when we talk about evaluation color differences, then we only talk about color differences and not different colors. That's very important later for the application, the limits of application of that media relative color reproduction type. So do we assess objects and printed products every time side by side, as the CIE colorimetry applies and tells us? And then mostly we'll see it depends. So we have, of course, different ways of seeing objects. On the left-hand side here, you see different banners and products seen in isolation. And on the right-hand side, you see typical side-by-side use cases where you have spot colors or where you have a trade fair stand and other applications where you see objects side by side, and you aim to have a close appearance match between them. So that's why you see there are a lot of use cases where you see colors, printed products in isolation. And since you see that in isolation, you can't compare. And if you can't compare, you use the color constancy mechanism of our brain or human vision. And that makes that you adapt to that individual scene and mostly this individual product. And that's why we call this media relative, because relative to the pertinent media you're looking at in this specific situation. However, the graphic arts, as I said, only uses side by side. So all color accuracy requirements, which you find in the ISO standards in different code of practices, are the application of side by side tolerances, XYZ, LAB, delta E values. All those delta E values you see reflect the differences which you see if you see them side by side. And not only delta E76, we use also more and more delta E2000 and replace it, but this is still the same concept. It reflects the color difference which you see when you compare those objects side by side. And there are different examples, 12647, soft proofing, and many, many more. But how many real print shops are actually in compliance? If all of you who runs actually a press and you check how much, if you see the ISO standard here, 12647-2, and you see the tolerances for the paper, how many print shops do you think actually are in conformance to those criteria with the white points defined in 1996, where this standard was published and those values were not changed in the revision of 2004. So, in my understanding and experiences, many print shops, practical print shops, are not in conformance with respect to that tolerances. That means if you actually do a conformance check with your control strip on your uncut print sheet, then you will mostly get this X, red X in the conformance protocol. And that's why, since we are using different shades of paper day in, day out, and since we sell them, we see, okay, there is something which we produce, a lot of printed products which we produce, but actually which we quite don't understand, or which we quite not are able to objectify. So we do it, we sell it, we are happy, we fulfill customer expectations, but we have no mechanisms to actually measure what we do, because if we use the mechanisms available, they fail. Or they tell us they fail. So what to do in that area, and especially in digital printing, where we see that paper simulation and digital printing is like Pope and double bed. So there is no such a thing. You actually don't do paper simulation mostly in production printing, because most of those products are seen in isolation, and that's why you adapt to it, and you don't want to have yellowish or whatever bluish paper simulation. And uh, when I said graphic arts used side by side only, I was not 100% true to you. Actually, the media relative technology is used much for a longer period of time, but not for evaluating the final color, but more for process control. So, and what I mean is tone value evaluation. And you see here on the left-hand side what is needed. It's a simulation of Fokker 39, and you see white, you see 100% sign and 40% sign. And the tone value, if you measure the tone value here on the left-hand side and on the right-hand side, it could easily be the same, but visually they look dramatically different if you see them side by side. But the concept of tonality, when you see images side by side in isolation, and the tone value reproduction is matched, then the color appearance is quite similar, and that is dates back to the work of Hunt and before, where the different tone reproduction curves are studied. So the concept of media relative handling color is already established. And many of you know that if you measure density, you null, you calibrate to the paper, and that's why paper has a density of 0, the media relative densitometry, so to speak. And that means it gives you the way to judge what's happened on that media with ink on that media, but it does not give you provisions to compare media to media. Because if you have 10 different papers and you null them individually, every of this different paper has a density of 0, so you can't use this 0 number to compare actually the differences in a side-by-side way. But if you ask people how those different papers appear in isolation, they will mostly tell you whitish, and that's why I would like to exemplify. So please have a look at that image, just a few seconds. And now close your eyes for a second and open it again. I presented a new, and you should now try to memorize. Do you see any differences? If you see that image now and compare from memory, is the white different? Are the skin tones different? Just from memory, what you remembered from the first image. Or just turn back, have a coffee like I do in a second, and have a look at this image. Of course, if you see the change immediately, you see a small difference, but just now let's adapt to that new presentation and let's adapt to that new screen. And now this is what people see. And now check, okay, do you see a difference compared to what you memorized? Is this a totally different reproduction of what you have in memory? If that would be the reproduction you see as a city light or on a bus passing you in downtown Marienplatz here in Munich, when you have signed the proof being the first visual. Or now this one. So you see, in that case, when we see all now side by side, you see there are bigger differences when you see them side by side, because then it is much the visual system is much more sensitive to those differences. Of course, I expect that the top right, the E426, the newspaper simulation, was quite of memorizable. So even if you have 10 coffees, 10 cups of coffee, you will still see that this is something different from your reference. So you see there are some limits of this media relative reproduction, and we will come to that in a second. But you must really question and ask yourself, did you see a difference, not in the 1 second where I shifted the slides, but really when you close your eyes and then you see the new one. And this is what we try to mimic when we say, here's the proof, have a look at it, and now turn away. Now you get the digital reproduction, for instance, have a look at them, judge it in isolation compared to what you have memorized, to what you have seen before, not side by side, and now say, okay, how much that differs from what you've seen and signed before. Here is the difference color-wise. Those are the four gamuts which I've compared, and for the techies, I have explained the way I did the calculations to actually get this sRGB images, which I incorporated in my keynote presentation, because I'm starting from isocoded V2, and then I do the media relative transformation towards typical actual printing conditions, because that's what print service providers are required to do. They get data prepared for an exchange space more and more, and not for individual press conditions, and therefore it needs to be retargeted or repurposed to the actual printing space. So why not transferring an established principle of color reproduction now for the graphic arts? We have seen we actually do this media relative technology already in densitometry. So yes, let's do it. We could simply do a conversion at the print service provider side. So that means we simply do this by just giving our printers this transformation and say, okay, uh, there are differences between your data prepared, like Focus 39, and your actual Indigo or Nexpress or ColorStream printout. So here are the new XYZ scaled values, and use that for conformance evaluation. But the problem with that approach, which is called paper correction by some people, uh, I think this is not a good way, because the print buyer will not take notice. So the print buyer will not be able to get informed about that process. And even if you do that at different sites, uh, there are different ways of doing it, as you see below, to judge what the actually human visual system sees or perceives. Because the XYZ scaling, which I will talk about more in a few slides, is one method of predicting what we actually see in the experiment we've done before. There are better methods, of course, which we can use for predicting these kind of corresponding colors, as a color scientist called this kind of colors. So the predictability will be lost. So if we do that at the print service provider side, this kind of media relative color reproduction, just by giving them modified aim values to be in compliance, that I think will only change my red axis in this conformance protocols to green checkers. But actually, this new kind of printout will not be able to communicate it correctly, because no one really understands how to digest this information. And if you have 10 different papers and you have this established principles, and all of those print service providers use a media relative evaluation, all of them will then have a green checker for the paper conformance, but customers see them side by side, then see, of course, huge differences, or might see huge differences, but all the protocols tell them, no, 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 there is no difference, delta E zero. So that's why this concept is so different, that I think we should do this from scratch, and we should draft that by a completely new type, an additional type of color reproduction, and communicate it upstream, and then gives the print buyer the possibility to decide, okay, which way of color reproduction is required. Will it be a spot color for a CI, which will be seen later side by side, then go the side by side route, or if you have use cases, print jobs like a banner or whatever, seen in isolation, go this way. And because the digital, especially digital print service providers, do that day in, day out, and that reflects daily practice. So now the first time we can actually give them provisions, mechanics to objectify what they do. And if you would like to get a bigger picture about this way, color reproductions, you basically ask two questions. You ask one question: how similar are your gamuts between your reference and your actually printouts? And the second question you ask is, do you assess the similarity side by side or alone in isolation? And then you see if the gamuts are similar and you judge them side by side. We do what we do for years and decades and use this kind of identical colors. If you have similar gamuts, similar in size and shape, and you see them in isolation, next, proof, turn around, have a coffee, show your print, and then judge it by this kind of memory we call about media relative colors. And some other types which will be researched are on the right hand side, which is a common appearance if the gamuts are very different, but you will see them side by side. I will talk about that in the last slide. And for very different gamuts seen in isolation, there are currently no provisions. Let's come to the actual implementation. And when we simplify our gamuts, we basically see that you have some separations at the beginning. If you prepare data for an output intent, for a printing condition like Greco, like Japan coded, like Focus 39, so ISO coded V2 in this case, this is something which are called separation and data preparation. And then when the print shop actually gets this data, then it mostly needs to retarget or transform it to the actual print, because that differs. In the PSO, in the offset worlds, if you calibrate your processes with a dedicated process calibration, then you can use that data and print one-to-one according to PSO and ISO 647-2. But for digital printing, mostly the actual printing condition differs, so you need to do a reseparation. And this kind of media relative reproduction actually fits in that specific place. And this is to visualize the limits of media relative color reproduction. As I said in the beginning, we don't evaluate and objectify something which we don't understand. And color science don't has yet objective means to evaluate huge color differences. And if you see from in our slide before, the differences between the originals, your scanner or working spaces, uh, additive, typical additive color spaces, sRGB, ECI RGB, Adobe RGB. On the left-hand side, you see here the wireframe, and compared to Focus 39, they're huge. So on the right-hand side, you see the projection and you see the delta E's, huge delta E's, where we don't apply the principle of color differences. And that's one more time in our simplify workflow overview. You see on the left-hand side, there are huge differences, and we don't objectify this at the moment. This will be later for color scientists to do common appearance, but we talk about on the right hand side, where we talk about differences in black points and white points and color between actually the reference and the actual print condition. And here the media relative reproduction applies. That is very important to notice. And now you might ask, okay, how to communicate that information to the print buyer? And if you read the PSD free of charge manual in German and English, here we provide an exemplary job sheet. And if you enlarge it, you see that these provides contents for the communication between print buyer and print service provider. And here you see, okay, which kind of color reference, which kind of color reproduction, is it side by side or media relative, and more information to communicate for predictability, for predictable dissemination of our compound entities, as ISO is terming them. Not ISO, the people behind ISO. And I think Leonard termed that phrase, and I like it. That is the way how we do it, applying the media relative reproduction. Basically, what we do is the same way as ICC since 1993 stores the color data in ICC profiles. So, and calls this ICC media relative colorimetry. And in order to find out that, 1 second, you will see here, if you see, let's say, for instance, Photoshop, and you make a new file, a CM/K file, and you see here on the right the 000 CM/K values, you see have a look here at the LAB values in a second, and you see, okay, 95 O minus 2. Okay, that looks like the white point here of that ISO coated. But if you go to the color settings and put some color settings which are typically like perceptual or relative, because those color settings will be used when you make a mode change, for instance. Where do I come from? Where do I want to go? Which rendering intent to use, like relative with black point compensation. Have a look now what you see right on that information. It is, and the interesting thing is, it is not for ISO coded. Even if you use something, if you assign a profile, let's use, let's say, Japan newspaper. Again, it is 100 because the data actually stored in that table, and which is now the media relative way of presenting it, it's 100. It's relative to the illuminant. If you now switch again to the color settings to absolute, you see 8005. So you see this is the white point of the paper encoded in the Japan Color 2002 newspaper. So the way of media relative colorimetry is, so to speak, very prominent in our daily life, but we mostly didn't realize. And you might also notice before, the white was displayed to the same way. The 100% white for the Japanese paper was presented the same way as ISO coded, because the way Photoshop displays this colorimetry, this data to the display, is also media relative. So that means this kind of media relative way functionality is already with us for many years, and most of us didn't really know that in that way. And here on the right hand side, I apologize for the German words here. We see that we compare the y, the luminance values from source on the x-axis to the destination on the y, and you see different ways of how to convert from source to destination. And if you see the black line, then you see the absolute colorimetric reproduction. So for the dark colors, which are below 0.3, everything will be clipped to 0.3 horizontally, and then if you can reproduce the colors 1-to-1, you see a linear slope toward the value of 0.7, and then when the white point is achieved, I've used a destination with a very limited dynamic range, you see here, from 0.3 to 0.7, and then so that means if you have colors inside that gamut, they will be reproduced 1-to-1, and if you have outside that lightness gamut, so to speak, they will be clipped either to the white or the black point. Red, you see media relative. The red curve represents, okay, everything to the black point will be handled the same, but everything to the white point will be linearly scaled to the new white point. And green is black point, media relative with black point compensation. So white point and black points will be compensated. And the blue one, this S-curve shaped one, is a representation of one exemplary perceptual rendering. And that's why when you see, okay, media relative might also clip some blacks, that is right, depending on the black point differences. And that's why we make sure that in the gamut similarity check, which I explain in a few seconds, we make sure that this will not affect the color reproduction, that we not get good media relative reproduction delta E's, but have a huge loss of shadow details and will then have an evaluation which actually gives good readings, but with a bad print quality when we consider now loss in shadow details as bad print quality, which is mostly the case. This is the way how we calculate them actually. So the first one, you see screenshots from our not so sexy Excel spreadsheet. You see a few colors patches, 4 color patches in on the left, on the right, which is a reference. On the right, you see LAB values of measured, in this case, FOCA 41 data for convenience. On the red delta E's are the 1976 delta E's. And the first step, this is very common. Every proof checker, every color difference evaluation, is this very old established principle. However, now the second step is now we convert it to XYZ. And that is a step which can be done mathematically. You can use some internet webpage like Bruce Lindblom to double check what actually goes on. You can do it on your own, but mostly software programs will do it for you. But this is a conversion like pound to kilogram or whatever, miles per hour to kilometers per hour. This is a hardwired conversion. Then the actual step now is the third, where we calculate the media relative value. So you see on the left side, we see what is needed to actually convert the white points, the 84 to 96, how to convert 87 to 100, and how to convert 74 to 82, because that are the XYZ values of the 50, 96, 100, and 82. Those are the XYZ values of our reference illuminant in the graphic arts, the 50. And so we actually only evaluate or derive three values, which will then be converted, will applied for all x values. So let's say the 84 needs to be multiplied by 1.2 in order to get 96. So all x values of all colors will be then multiplied with 1.2. And the same for y and for z. And you see then in the third paragraph here that we have the same white points. Actually, we have the reference now scaled to 9682. On the right side, you see we have the measured value scale to 9682. So that is a main fundamental of media relative evaluation, that the delta E, and you see it in the last paragraph, the delta E between the paper white is always 0. Here we have scaled the reference and the print to 100. You can also do the same principle by just scaling the measurement to the white point of the print, but I think it's more convenient to do it this way. And on the right hand side, you see that we don't apply delta E76 anymore. We do it now with delta E2000 because that is a better color difference formula. And I think if we do some work from scratch, we can use and we should use modern color difference formulas. Whereas for established principles, I think it's not a good idea to use delta E2000 because we just use complicated or different ways of telling the same story. And at the end, you just apply the gamut similarity difference because we have learned only use this method when there are small differences in gamut size and gamut shape, and then apply an appropriate multi-level tolerancing, which is governed by the industry. What is actually required? What is a 5-star hotel? What is a 4-star hotel? What is a youth hostel? What is the industry asking? And only do what the industry is asking and try to balance that wisely. This is the Excel spreadsheet which you can download from the website. So again, let me go to our website here, switch to English, and if you go to research, no, sorry, to focus search, print, and then you see PSD and download. You can then download the manual, the handbook, some ICC profiles, and here's the Excel spreadsheet to download. And this is the CAE Delta E2000 plugin. If you install that, then you actually can calculate the Delta E2000 with your Excel on your own, not only for this spreadsheet, but also for everything else, because Delta E2000 is a little bit more complicated to implement in Excel on your own. This is an overview of our Excel file. You see it's quite huge, so let's navigate and let me walk you through that huge Excel spreadsheet. You see on the left side the normal reference values, media wedge 2, media wedge 3, 72 patches, and on the right hand side the green ones are the measured ones from your print to evaluate. Whatever print it is, it's a print with a media wedge and you measure it very normal. There's no difference in measurement. Then you calculate the media relative T-lab values, as I explained before. Then you check the similarity of gamuts. You might see it in the middle of that spreadsheet, which is called gamut mismatch. And here we evaluate the differences in white points and black points, and then see which kind of similarity it has. And here we have 3 levels of similarity: A, B, and C, and we check how close actually are the differences, or how close are the gamuts with the reference and the actual gamuts, and we estimate them by the differences in black and white point. And based on that, we then do the evaluation, the Delta E2000 evaluation, which you see on the right hand side with the red solids or with the red line around it. And again, remember the delta E for the substrate for the paper must always be 0. That is something you can check, media relative evaluation. And what we do actually is we just do the average and the quantile of those 72 color differences, but only if the gamut similarity has passed. So if the gamuts are not similar, we will not do any evaluation, which you then see on top. And you see also on top side by side. So on the left hand side, you see different ways to evaluate a proof, a validation print, PSO, and also 15311, so digital printing by means of the established side by side. But also on the right hand side, media relative, we call it single stimulus, by means of just the delta E in average and the quantile for our 72 delta E2000 color differences. And depending on the gamut similarity, we have 3 currently types or 3 quality levels, which represents the closeness of the visual appearance or the closeness of the match, and we call them A, B, and C. So A being the best, the 5-star hotel; B the 4-star hotel; and C the 3-star hotel, if you wish. And also you see two values for you get a B, and C for average and the quantile, and here the minimum tolerance rules. So that means the biggest, the weakest chain, the weakest member in a chain determines the entire quality. The same is here. So if your average is A and the quantile is B, then that entire print is B, and it is not intended that the different categories are handled individually. Yeah, okay, I missed that. This is a normal way, and this is a manual way for you to incorporate and to do that media relative evaluation on your own. However, there are many companies right now working on that to provide software to make this easier for the user. And as I know, there is the Color Arena, and there is Caldera software available, which does this media relative evaluation. There's also from Catch a software available which can do this. But I think in the next months to come, we will see all the big vendors of evaluation software to offer a side-by-side established evaluation and a new media relative evaluation to actually represent what to do here. I remember myself when we introduced the media wedge with the ugly Excel spreadsheet in 1997. It was quite of ugly, but technically correct. And more software providers provided nice software, which does the same job but much more nicer and easier and not so tedious. Here again are the different columns for those who would like to see what actually goes on. They can have a look at the detail transformation. So coffee is now cold. Yeah. Okay. Now you see what we have, what I've just told you. This is different. And the visualization, if you see now more from a graphical point of view, if that is too technical, that is the way you know right now. You have different gamuts, and let's say here Foca 39 and Foca 45 for web-based printing on lightweight coated, and you see the differences also in the white point, in the projection of in the AB plane. But if you do the media relative, you see that the white point will also always be centered, and the difference in the white point will always be nulled. And that's why mostly because nature normally don't make jumps or doesn't jump, the differences between the other members, the color pairs are closer. So that normally means that the media relative color differences are smaller than the side-by-side differences normally. And that is what you typically see. If the paper shifts, the human, the visual the eye, the human visual system adapts to it only also, and that is the ICC media relative mechanics to reproduce it. And of course, we will see at the end there are other methods available which try to do the same, predicts this corresponding colors to a better in a better way. That's right. But for the time being, we keep it that way. Okay, that means with that being said, we have different levels of predictability. I would say because if we don't have predictability, we don't use FOCRA, we don't use standardization, because if you want to print something sexy, you don't need us, and you can do it. And but this means if you have a PDF sent to 20 print jobs, you get 20 originals, and if you send the same PDF 10 months later, you will get again 20 originals. So that's kind of the way we try to uh, communicate that way. So here with PSD and standardization, we try, if people want, and I think these are 10-15% of all use cases where color is critical and predictability is important, that the creator can get some means, provisions of what to expect later. But this kind of expectation differs. And we've learned today that there is the highest level of predictability in the established side-by-side evaluation, and the bigger the delta E, the bigger the color difference is seen side by side, and there are different standards and principles used so far for that kind of identical colors. The new way of color reproduction now, as introduced, is media relative colors, introduced in the ISO 15311 standard series and in the PSD. And it is applicable for small differences between reference and print gamut. You compare actually with the memory in isolation, not side by side. And that is also important later if you use it. If you use it in reality, so to speak, don't judge media relative and then compare it with your customer side by side. Of course, you can do it, but that's not what the numbers reflect. And in future, we work also on what we call common appearance. This is active field of research where we judge colors side by side, but with huge gamut differences where there are technically, physically no similar colors possible, but still some. We try to find some mechanisms, some color signs where we have different instances of one original, and we would find if they have something in common, if they share some common appearance, and if we are able to objectify that in the future. That is called common appearance, and we call it here partial color reference. With that being said, I come to the end of this webinar, and we will start the question session if you have some questions. So The side-by-side color reproduction is established for decades and used successfully. ICC media relative colorimetry is used for storage of color data, as we have learned, but not for, and now for evaluating the reproduction also of color data. So we can actually objectify what many, not only digital, also conventional printers do. However, there are some points of further research, and this is also part of a project we will start in February next year to go into detail and see how to take care of black point compensation. How can we incorporate the black point compensation that this kind of potential shadow detail loss can be not only reflected but also embraced and enforced. How to extend the gamut similarity check beyond checking the white and black. So currently we just check white and black differences, but also we now take a closer look. Should we also check the color gamut differences between the reference gamut and the actual print gamut? So this is another point we will have a look at. And last but not least, I always invite you to join our digital printing working group or our groups here at FOCRA to join that research and not only digest the results but also contribute and help us standardizing this provisions and this mechanics in the future. Thank you very much for your attention and see you the next time. Okay, now it's time for some questions. So if you have a question, just raise your hand. You can use your raise hand button and I will unmute you and then you can speak up in case something is not being said or not being answered. Oh, Claudio has a question. So just, it's your turn, Claudio. Oh, you have no microphone. Okay, I see the question. What are the steps to take if one wants to prove hard copy or monitor proof data used in a media relative reproduction chain? Does it make sense at all? Hard copy or monitor proof data used in a media. That's a good question. So I would say it makes no sense at all because hard proof and soft proof are use cases per definition which require side by side evaluation. So if that is required, so it is the nature of that kind of use case, and therefore, if you don't see it in isolation, you don't need the mechanism which reflect colors prints seen in isolation. So that's why the answer is it makes no sense at all. Are there more questions? If not, you have seen my email address below, so don't hesitate to drop me a line. And tomorrow morning we will have the same in German language. So with that being said, again, I thank you for your attention and for your contribution. I wish you a nice day and talk to you later. Bye bye.